So the title of the paper is Brain-Computer Interfaces for Communication in Patients with Disorders of Consciousness, a Gap Analysis and Scientific Roadmap. And this is a paper put together by 16 experts of varying backgrounds and experience in disorders of consciousness. The panel included people across the United States, Europe, United Kingdom, and the Middle East, and represented 16 different academic medical centers, neurologists, neurosurgeons, physical medicine and rehab, neuropsychology, and neuroscience. And what we did was we met as a working group bi-weekly and performed a gap analysis of a primary question, which was essentially aimed at what can we expect, what has been done with brain-computer interfaces in disorders of consciousness, what is important to trying to think about how they could be brain-computer interfaces could be brought to disorders of consciousness, and what the challenges are both in adults and pediatrics. And I should probably say that what is a brain-computer interface? It's a system that, by the definition, it's a system that records neural activity from the brain, translates it into an artificial output that replaces, restores, enhances, supplements, or improves natural central nervous system outputs, modifying the ability of the central nervous system or the brain with the rest of the body to interact with the external world. And we spent a lot of time, in addition to our collective expertise, we spent a lot of time surveying the literature that we thought was relevant to this topic. It was a very widely cast literature review that involved both diagnostics of patients with disorders of consciousness, different methods for recording from the brain, different methods for interacting through brain-computer interfaces that we discussed their usefulness in disorders of consciousness, and canvassed and reviewed efforts that had been made mostly with non-invasive brain-computer interfaces to make contact with patients with disorders of consciousness and to provide them benefits. So one of the first things that emerged in this discussion, and I think that it's sort of a key finding, is that we came across certain conceptual pieces that needed to be highlighted and brought out in the literature and used to organize and frame our research thinking. Because I think if we go back and we look at the paper itself, it has very specific clinical and research recommendations. And the first clinical recommendation, the first sentence is, it's of paramount importance to clarify or to clearly define BCI readiness. Well, what does BCI readiness mean here and in this disorders of consciousness population? And what we found was that we came to a consensus that the field right now has enough information to start testing existing tools, if we put them together, for making an assessment of patients with disorders of consciousness as to whether or not they are BCI ready. And what we meant by BCI ready here was that we could just detect a signal that could be used and tested as a way for a device to translate activity in the central nervous system to produce an output useful for control of another device to allow interaction with the outside world. And we focused on communication because for the patients with disorders of consciousness, this is the most meaningful, ethically salient, and then practical and actionable function, if it's possible, to restore for them. So, and in that discussion, one thing that emerged in our working group that was very important, it was another sort of conceptual piece, and I think to my knowledge, novel to this particular paper, was a clear distinction between what we decided to call one-way versus two-way communication systems. And this grew out of our collective experience working with patients with disorders of consciousness at the bedside, either with gestural communication or with existing augmentative communication technologies, which could be considered a very basic brain-computer interface. And that was that, for the most part, patients with the disorder of consciousness only established one-way communication systems if they were remaining in a disorder of consciousness, so that you could ask them a question and with some reliability get a response as a form of communication on top of a on top of a command following response, where you could ask somebody to either do something physically or imagine doing something, or do something physically when they couldn't do it, and you could detect a neural signal where they could. That was tested by many papers, by the experience of the experts in the group in many patients. And while a one-way communication system, if there has not been a way to communicate with the patient, is an extraordinary step forward, it's not really what we are aimed at in terms of trying to help patients who have the capacity to communicate. And we drew this distinction between one-way and two-way also because the advances in brain-computer interface systems that have been rapidly moving forward over the last decade have generated two-way communication systems that are highly effective, intuitive, in the sense that they do not require the kind of demands of high-level cognitive work that many of the technologies that we apply to making a diagnostic of an internal state in a disorder of consciousness patient being present that was cognitive. Most of that work is done with fMRI or EEG measures that require several minutes of effortful cognitive activity. The new intuitive intracortical brain-computer interfaces allowed cursor control and most recently speech to be generated just by the intent of the user to either move or talk. So, we had some very specific research recommendations that the paper put forward. One was to develop a validated hierarchical protocol to assess this BCI readiness that could be used to stratify patients for research studies. We also wanted to point out that many patients who are BCI ready start to have changes and improvements over time, and in some cases rarely begin to recover their own ability to establish communication. And several examples of that are in the literature. So understanding that biology, which would probably be an excellent model for the biology of the aided recovery process with BCI tools brought successfully into BCI ready patients with disorders of consciousness, would be another key piece. But then I think what we all could see as the critical next step for proof of concept and breakthrough here is to take the patients who we call patients with cognitive motor dissociation, who may show some signs of consciousness. In fact, most of them do in the studies that exist, but don't even show a single visible behavioral way of indicating a command following, yet harbor high-level cognition and try in demonstration cases to use the existing invasive brain-computer interface technologies to see if we can establish a two-way communication. That's, I think, going to be something we will see happen in the next 5 to 10 years, and it's going to be highly operational. It's the equivalent of what was seen in the recent paper that was published in the New England Journal by the BrainGate group, where a brain-computer interface was able to learn a 250,000 word vocabulary within a day, and then allow a patient who couldn't speak to speak in real time. if we can hear a CMD patient speak in a synthetic voice modeled from their own voice prior, or communicate through a cursor through their thoughts, I think on a computer screen, I think that's going to be the major next step breakthrough. And I'm certain it's going to happen because, as I said, we've seen in the natural history that sometimes people spontaneously get to this level, and that can be over years. And we don't know the rules of that game, but presumably many patients who had that latent potential just haven't been unlocked. Well, in fact, you've already seen this in the literature. So this study I mentioned from the New England Journal, where a synthetic voice was in real time recreated so a patient could speak continuously from a BCI, that process of organizing the neural information for coded speech intent and translating it into the patient's AI modeled voice was all on the software side, aided and supported by AI. So AI is going to be a critical algorithmic tool in the mix of the translation of hardware sensor hardware, detection of signals, and then the organization of the information coming out of these high dimensional data sets. I think that, this is a really important area that's been very neglected. I think that chronic disorders of consciousness has been an area that's been difficult to get funders interested in. I think there's been, up until very recently, a sense of futility about being able to help anyone like this. And I think there's also just been a lack of real absorption of what's been studied, learned, and understood now about the variation of levels of capacity that become recovered over time in a large number of such persons. And I think that's a real target for us to make progress on, and we have all the tools that exist to do it.